What you see here, this is where we have our input, and this side, this is where we have our output. So we need to analyze this circuit. Okay, so the voltage input, and this is where you get your voltage output. And the question is, can you solve for the current? So this is in case where we're asking you to find the current in S domain. Okay, so in this situation, what do you do first? We need first to get to analyze the circuit using Kirchhoff law. Kirchhoff is law. Okay, we do have a Kirchhoff law for current and Kirchhoff law for voltage. Okay, so the input voltage, the one that you see here, will be equal to the sum of the component that we find into the circuit. Okay, so it's gonna be VR plus VL. That's gonna be in terms of voltage, and in terms of current, we know that you get your current inside the same formula that we use for the voltage. It's gonna be just similar to what we're gonna get. You can see here from VR we have the current there, and even this one we still have the current inside VR. So the formula is gonna be exactly similar with the law of Kirchhoff. So what we're gonna get here, we'll get something like this. Equal, so the input current equal to the sum of current within the circuit. So it's gonna be this one times R. Okay, it's this is in terms of voltage. So when we speak about current, it's gonna be something like this in times domain plus the current across the inductor. Okay, so this is what you get using the Kirchhoff law for current. Okay, and in terms of voltage, it's gonna be the input voltage, okay, plus the resistor voltage plus the inductor voltage in times domain. So what you see there. Okay, and if you want to go now you got this information from this loop. We only have one loop, and it's actually loop 1. We don't have any other loop, so we only have one loop. And then the way that we did to solve it, we made this arrow, circular arrow, and then we add the voltage starting from V in equal to the sum of the voltages we find across the circuit. It's gonna be VR plus VL of T. Okay, that's what we get here on this voltage law. And if you want to solve it further on, you're going to replace each VR with this formula, okay, and VC, just to adjust it. Okay, as you can see, I've adjusted both formulas this side. I just added just to show you the times domain, just to tell you this voltage is in times domain and this other voltage are in S domain. Not the same with what we get inside. So meaning this one also, it's what we get in times domain. Okay, so what we're going to do next here, we're going to replace, okay, all this value into this equation that we got here. So what we're going to have for the this equation is gonna be something like this. So it's gonna be the VR, it's gonna be something like this. So R plus VL d dt caret of I. Okay, so this is what we get for the when we replace the value. This is what we get into the formula. Okay, so when we're going to replace the formula of the current into that equation, this is what we get. Okay, so now once we get this equation, we have the option, which if we want to work in S domain, okay, we can now apply the Laplace transform to get this form. Okay, so this is where you're going to apply your Laplace transform, depending on if you're working with Laplace. Okay, so this is where you're going to apply the Laplace transform of both sides. So, and the reason why we're using Laplace here, it's to convert, okay, to perform the conversion, okay, conversion from times domain to S domain. This is why we're using Laplace here, just to give us an option where we can actually solve this equation easily. Okay, so depending on where we're going, you're going to apply this. This is what we're going to apply here, and the formulas for Laplace is gonna be something like that. So if you apply Laplace to this equation, and you apply Laplace to this other equation, you will get something like this. So it's gonna be vi of S. Okay, it will be equal to, okay, it will be equal, let me just write this equation correctly. So let me just write it correctly. So since we're moving from times to S domain, that's why we're making it the current in capital, and everything else has to be in capital. So we're gonna get something like this of R plus L S I S. Okay, so once you get this equation, you can now solve for the solve for the current. Okay, so if I have to look to solve for this for the current that you see here, I'm going to put it in evidence. So it's gonna be, I'm gonna get something like this, equal, it's gonna be current S, okay, and then you open plus LS, okay, and further on we need to solve for this current. So it's gonna be something like this. So if you have to divide to remove this one this side and move it the other side, you will get something like this. You will get something like this, V S, the current input, over R plus LS. Okay, so this is what you're gonna get here. And further on, if you want to solve for, okay, this is what we get for our current. So let's just stop here for now. Okay, we're going to stop here for this question. It was just to show you how we can get these formulas from the circuit that you have there. Okay, so let's move on to another example.